Okay. You guys can. It's going on, yeah.
It's going on. 1, 2, 3.
Happy birthday to you. Happy birthday to you. Happy birthday, dear Jennifer.
Happy birthday to you.
So if any of you guys still have birthdays left, okay, guys, let's get started. So, all right, let's get started, guys. For the first one, we have to sketch the region and convert to polar coordinates. And evaluate. So they gave us in rectangular coordinates. Okay, so the way to do this is to always look at which order you're going first. Okay, so in this case, we have dy first. So that's how we know that we're going from bottom to up first in terms of the limits and looking at the functions they give us. So for the first part of this region, and we know there's going to be two regions since we have two double integrals, we're going from 0 to x. So 0 would be this line where y is equal to 0, and this line is equal to y equal to x. And then it can go on however far. Okay? From the dx position here, we know it goes from 0 to 1. So this spot right here is where x is equal to a 1. Okay? That's region 1. And in the second region, we are going from 0 to y equal to the square root of 2 minus x squared. Okay? If we simplify that by squaring both sides and bringing x to the other side, we get x squared plus y squared equal to 2. Okay? So that means there is a circle here with a radius of 2, or the radius of square root of 2. Okay? So this is equal to r squared. We know that the radius is equal to square root of 2. Okay? And it also works out because if the radius is the square root of 2, then the distance from the origin to the point where it touches the x-axis has to be square root of 2. And it works out because we know here it shows the limits for x, and it goes from 1 to square root of 2. So we know we did our math, right? And we can label this as x squared plus y squared equal to 2. Okay. Any questions on that? The second part is to convert it into polar coordinates. So we have our square roots. So our function is x times y. What is x equal to? R cosine of theta. What is y equal to? R sine of theta. And then what is dy dx equal to? Yep, r dr d theta. So the first thing we look at is with dr. So r starts off at 0. What is its upper limit? radical 2. Now, don't make a mistake of just going with theta equal to 0 to 2 pi, because in this theta is obviously stops at where y is equal to an x. So this is our theta value. And what would that be? Pi over 4. But if you didn't know that offhand, y is equal to an x. That means r sine of theta is equal to r cosine of theta. Sine of theta divided by cosine of theta is tangent of theta equal to 1. Theta is equal to pi over 4. And that's how you would calculate that. So then our theta goes from 0 to pi over 4.
Did you know r goes to square root of 2 just because it's like the max value can be?
Yeah. From the origin to the outer end. Yeah. Okay. Do you guys want me to solve this out or just give you?
Always.
You want me to solve it out? Okay. So right here we have 3 r's being multiplied, so that's going to be r cubed times cosine times sine. Okay. First we do the integral in terms of r, keeping the rest constant. So we get going from 0 to pi over 4, r to the 4th divided by 4 times, and that being evaluated from 0 to square root of 2 times sine of theta, cosine of theta, d theta. So looking at only that part, we have 1/4 times square root of 2 squared. Square root of 2 to the 4th power is what? 4. Because it's 2 when you square it and then you. So 4 minus 0 on that, which is equal to a 1. So then we look at this section. Okay, what can we use here? U substitution. U is equal to sine of theta. Du is equal to cosine of theta. D theta, which we have right here. Okay. And I'm going to erase actually this part to keep it on one screen. So then that is equal to sine squared theta divided by 2, going from 0 to pi over 4. Okay, because this is equal to a 1 here. What is sine of theta, or sine of pi over 4? So 1 over square root of 2, and that is squared minus 0 squared. Okay. So this is 1/2 times 1/2 minus 0, which is 1/4. Any questions on that? Yeah.
In the sketch, do we have to put like theta and r as well?
You don't need to put theta, but you should label your boundaries, the curves. You actually don't want to show this part. I don't think it would take points out because you clearly label it, right? But so any other questions on this? It seemed pretty straightforward, right? Okay, 6, 8. We have to convert from rectangular to spherical. X squared plus y squared plus z minus 1 quantity squared equal to 1. So what's the first thing we should do? Expand that. So we want spherical. So we have x squared plus y squared now plus z squared minus 2z plus 1 equal to a 1. So right away we see something that we can change.
Yeah.
Is that what you said?
Yeah.
Yep. So x squared plus y squared plus z squared is equal to rho squared. The ones actually go away. And now we have minus 2z left. What is z equal to? Rho cosine of phi. And that's going to be equal to 0. Yeah. If you divide by rho, then you have like that. You shouldn't divide by rho. You should factor to find all possibilities of rho and stuff. Because you're trying to convert it into spherical, you want to know what rho is equal to, essentially. So do you guys understand how we got this far? Okay. So what do we do right now? Factor out rho. So it'd be rho times the quantity of rho minus 2 cosine of phi equal to 0. Okay. So this tells us two things. That rho is equal to 0 and that rho is equal to 2 cosine of phi. So if you divided by rho, you wouldn't have known that rho could equal to 0. Okay. But so you could either put both of these as your answer, or you could just circle this because at some value of phi, rho is going to equal to 0.
So included.
Yeah.
How do you know the best way to if you're solving for
You're trying to get into spherical coordinates, right?
Yeah.
So spherical coordinates are made out of rho, phi, and theta. So once you reach this point, you're done.
So you could always solve rho equals something.
Not necessarily. You could just have a value for phi, and that's spherical. You could have like a term where rho is equal to something with cosine of phi, something with theta, like sine of theta or something, and you'd be done there. The point is to get to rho, theta, and phi, and then simplify it if you can. Within like, so if we were dividing, or if we had sine of phi divided by cosine of phi, we would put tangent of phi or something to put it in simplest terms. So any other questions on this? For B, we have to convert z is equal to the square root of x squared plus y squared divided by the square root of 3. Okay. So what is the most obvious thing we can do right now? Yep. So x squared plus y squared is normally equal to r squared, but when we do the square root of that, we get that z is equal to r divided by square root of 3. Okay.
So R, we don't have to do absolute value of R because R can't be negative.
Yeah.
R and rho both can't be negative, right?
Like
Like it would be the opposite.
because it's always, so you know how you learn like different methods to like naming stuff. You could have negative r, but then theta is like something weird and stuff. So you can essentially always have positive rho and positive r, because it's just a longer theta if it goes to the
Okay.
stuff like that. But whenever I've done it, I've just treated it as positive. So we know the value for z and r in terms of spherical coordinates, right? So what would that be? What is z equal to? Rho cosine of phi equal to r is equal to what? Rho sine of phi, and we are dividing everything by square root of 3. So in order to now, so again, we have everything in terms of rho, phi, and theta, but you can simplify it right now. So the rho's can cancel out. We can bring cosine to the other side. So we'll have sine of phi divided by cosine of phi, right? That's equal to tangent of phi equal to 1 over, or equal to the square root of 3, because we brought it to the other side.
How come you can cancel out the resistance?
Because we're just trying to put it in simplest terms now. In this, what happened was if we had crossed out rows, we would have lost that rho could equal to 0. And we could have factored it in this. If one of these was squared, then you could try to factor it by bringing them to one side and get it in terms of rho or something. So essentially, when you can factor it. But when it's out to the same power or something, just try to work with what you have and simplify it. So what is phi equal to? Pi over 3.
How do you know we're only in the first quadrant? Why don't we do all the angles until 2 pi?
So when you drive in 3D, we're not just looking at the first quadrant. We are looking at all of them. So do you remember what phi actually means?
Mm-hmm.
It's the angle coming from the z dimension. So that's phi.
Off the x-axis.
It's from the z-axis, so that's phi. Okay? So we can pretend that phi will always be positive if this is going in a loop around the origin or something.
Right.
So essentially, we don't need to worry about it. But because we can treat it like that, I mean, you can call this something, a negative or,
Got it.
But-
The same.
So those are our two equations in spherical coordinates. Now we need to sketch this. So are you guys good with whatever is written here? So we got that rho is equal to 2 cosine of phi, and that phi is equal to pi over 3. And they tell us that it's bounded above by this equation and below by this. Okay. So when it's bounded below by this angle, we know it'll be something like that essentially, right? Because that's the theta coming out of the z-axis, like that. To know that rho is equal to 2 cosine of theta, that's like knowing that r is, whenever you have an r value, it's like a circle, right? So then when you have something with rho like that, you can, essentially all of the time, it'll be like a hemisphere or a paraboloid on top. So it'll be like that.
Is that a sphere or paraboloid?
It's like the hemisphere, like the top.
Yeah, it's like the top.
Yeah.
part.
Is the angle supposed to be theta equals pi over 3 or?
Oh, sorry, yeah, phi. Thanks. Don't mix those. And if you don't really like that analogy, you should know that x squared plus y squared plus z squared, anything equal to number is like a hemisphere. So that's why it's like that. So any questions on drawing it? No? Okay. So then after you draw it, it shouldn't be hard to write the triple integral with the limits. What goes right here in spherical coordinates? Rho squared sine of phi. Don't forget that. In cylindrical, it's always r. In spherical, it's rho squared sine of phi. D rho, d phi, d theta. So phi goes from 0 to what?
You said 5.
Sorry, not phi, rho.
Yeah, 2 cosine.
Cosine of theta, 0 to pi over 3. And then theta goes from 0 to 2 pi. I'm forgetting the term, but what's the J name? The Jacobian. Sorry. This is essentially this is the Jacobian to convert from rectangular coordinates to spherical coordinates. Okay, if you do all the math, and you find the Jacobian for converting from rectangular to spherical, you would get this. For converting from rectangular to cylindrical, you would get R. So that's why we need to multiply by this, because we already did the math in converting from our x and y equations to spherical, but we still need to multiply by the Jacobian to make the conversion. So you guys want me to solve this out? Or? Yeah. Okay. So we have rho squared, so that's going to be cubed over 3. Going from 0 to 2 cosine of phi. So now we still need to multiply by sine of phi, d phi, d theta. So let me just. So you guys understand why theta was 0 to 2 pi, right? If they told us to just be in the first octant, right? What would theta be equal to? 0 to pi over 2, right? Oh. Okay.
It looks like for most 3D stuff, that'll be the 2 pi, right?
Yeah.
It's like usually around
If they don't put a restriction and just say the first octant is 0 to 2 pi. Okay, so this is equal to 1/3, going from 0 to 2 pi, going from 0 to pi over 3, square root of 5, times here. So they make both of them negative. But we'll get to that. So what would this be? 2 cubed is 8, right? So that's 8 times cosine cubed 5. Or is it 5? No, it's actually.
It's 5. We haven't done theta yet.
Yeah, they put theta here by mistake. Okay. And then minus 0, so we can just ignore that. Times sine of phi, d phi, d theta. Okay. What would our u be in this case?
Cosine phi.
Cosine cubed of phi du is equal to 3. Yeah. Sorry. that would be easier. Cosine of phi. Du is negative sine of phi. So then we need to multiply by a negative 1 here. That means we need to multiply by a negative 1 here. So then we have du right there. So then this is equal to a negative 8/3 going from 0 to 2 pi, the integral for theta. And then we have the quantity of cosine to the 4th of phi divided by 4. And then phi is going from 0 to pi over 3. And then we have d theta. Can you guys see that? Or, yeah. Okay. Is it okay if I erase this side? Just to keep it on the same board. Okay. So we did a u substitution. So we have 8 and a 4, so we can have a negative 2/3 on the outside. Then we have cosine to the 4th. So cosine of pi over 3 to the 4th power minus cosine of 0, and that's to the 4th power. And that's one term. And then if we were doing the integral of d theta, what would we get? Just theta going from 0 to 2 pi. So this. So what is cosine of pi over 3? 1/2. So we have 1/2 here. That's to the 4th. What's cosine of 0? 1. So we couldn't ignore 0. So we have negative 2/3 times the quantity of 1/2 to the 4th power, which is 1/16, minus 1 to the 4th is just 1, times 2 pi minus 0, so we can just write 2 pi here. So 1/16 minus 1, that's equal to negative 15/16. You guys see that? Because negative 1 is 16/16. So just trying to simplify this, we have a negative 4 pi over 3, combining 2 pi and negative 2/3, times a negative 15/16. So the negatives go away. 15 divided by 3 is a 5. The 16 divided by 4 is a 4. So we get 5 pi over 4. And we have length cubed. So, any questions on this problem? There was a lot of simplifying. Yeah? You guys still copying it? No. You guys have it copied?
Yeah.
Okay. So for number 7, we have to sketch the solid. bounded below by z equal to 1, and on the top by z equal to 5 minus x squared minus y squared. Yeah. So we know there is a circle essentially where z is equal to a 1. Well, that's like a plane. We know it's a circle because of the paraboloid where the height of it is a 5 when x and y are 0. And then it's essentially circles getting bigger and bigger as you go down, right? Because we're increasing x and y values, so we get a lower z value each time. And then we can write 5 minus x squared minus y squared, or we can just say 5 minus r squared. You can do either. Part B is to sketch it in the x and y plane. What would that look like? Circle. What would the radius of that be?
You do that because you set them equal to each other.
Yep. So we set these equal to each other because what goes on the x and y plane is the biggest circle possible, and that's when z is equal to a 1. So 1 is equal to 5 minus r squared. R squared is equal to a 4. R is equal to a 2. Any questions on that? Part C, we have to find IZ. And we have to use the optimum coordinate system. So in this, what do you guys think is the most optimum system? What? It would be cylindrical. Yeah, I didn't hear you guys. Because we have everything right now in terms of z and r, and we know theta is going to be 0 to 2 pi, right? So it wouldn't be hard to write out the limits for this. If we were to use rectangular system, we need to go back to x and y and do integrals with them, which would get confusing. And if we were to try to convert everything to cylindrical, how would you? It is possible, but it'd be very messy to limit phi and rho with those equations, right? Because phi would go from 0 to the end, but then you need to find phi starting at z equal to 1, and then work, to the end and find rho that way. So the best way to do this is with cylindrical. Do you guys all agree with that? And on the exam, if you don't, if you choose a method and it turns out to be really messy or something, that's fine. Like if you're already too far into it, go ahead and finish the problem and write some answer. Don't waste time, erase everything, redo the problem. So, just try to finish the exam. And then if you have more time and you think you can go back and redo it all, like you have enough time, then go for it. Otherwise, you should get some points, even if you use the wrong method. If they tell you to use a specific method, you use that method, right? You don't do any other, because then you won't get any points. Good? So we have the triple integral of, what do I write here for IZ?
R squared.
X
R
squared
squared.
plus Y squared.
It is R squared,
Oh, yes.
but essentially it's always x squared plus y squared, which in this case, since we're using cylindrical, we can just write R squared. And then we always write what if we're doing cylindrical?
R still R d theta density.
R, but essentially in this, what do we want to do first? dz,
I forgot about DG. I didn't write DG.
dr d theta.
It's also U.
Okay.
Okay, so, sorry. The DZ, when do we start, do we do that for both cylindrical and spherical volumes? Or is it just?
Spherical doesn't have z.
What?
Spherical
Okay.
doesn't have z.
Okay,
Yeah.
yes.
There's rho, phi, and theta.
Let's write the limits.
So what are our limits for z?
1 to 5 minus R squared.
Yep. R is, what are the limits for r?
0 to 2. Oh, is it to 1?
0 to
Oh, it's 2.
2, because we
You're right.
found right here. That's why we always write in the x and y system for this problem, in the 2D version, to find those limits. And then theta goes from what?
0 to 2 pi.
0 to 2 pi. And we are forgetting one more thing,
No, we didn't. Density.
density.
That's
Okay?
constant. So you tell us.
And in this case, density is constant, so we can just write it like that. So you always do need to write it. On this old exam, they say it's fine if we treat density like a 1 in the grading. Okay? So in the grading, they were lenient and they didn't take up points when people forgot density. But having said that, that is, they may not do that with you guys. Yeah.
So if they said find volume, you would do, it's just nothing in the inside, it's just 1.
So
There's
then
no integral.
in our answer, we multiplied by density as our answer. So there would be a constant, whatever you call that. So I think we have enough time if I solve this out too. Okay. So this would be r cubed. So then we'd have r to the 4th over 4. But, sorry, we don't do that first. We do dz first, right? What's the integral of dz?
You're misleading us.
Just a z. All right.
That's how I get it. I didn't write back the next email to read it.
So we have density times 0 to 2 pi. From 0 to 2, that's the limits for r. And then we have z, which we took the integral of dz. That's going from z equal to 1 to 5 minus r squared times r cubed dr d theta. That's equal to phi minus r squared minus 1. So then that is 4 minus 1 times r cubed. So then this is 4 minus r squared. Did I do that correct? They might have done something wrong on here. But we'll go with this. Okay. So we multiply r cubed across, so we have 4 r cubed minus what? R to the 5th. Since we multiply the r values, we add the exponents. So that's r to the fifth, and that is, dr. So we take the integral with that. So we have from 0 to 2 pi, density on the outside. The integral of 4r cubed is what?
R to the fourth.
R to the fourth minus, what's the integral of r to the fifth?
R to the
6 over 6. And that is going from 0 to 2. And then we have d theta. Okay. So we have density times, first we plug in 2, we have 2 to the fourth, which is what? 16. What do they have? So I'll just 16 minus 2 to the sixth. Okay, yeah. We'll do 64 over 6 for now. Minus 0. So it's minus 0. Okay? And then we have the integral of theta, which would be theta going from 0 to 2 pi. Right? So then all of this is being multiplied by 2 pi. So this is what they did in order to simplify. Or we can just do this. So this was, we said 32 over 3. Right? What is 16 times 3?
48.
48 minus 32 divided by 3. That times 2 pi. Okay. What's 48 minus 32?
16.
So 16 over 3 times 2 pi. And that would be 32 pi over 3. And then we still need to multiply by density. Any questions on this problem? So far, I don't think you guys have had much trouble with the exam. No? Did I draw out the Jacobian shape? Yeah. Okay. So, any questions on that? No? Are you guys good to move on? Finish this up? Okay. So we have x is equal to u minus v over 2. Y is equal to u plus v divided by 2. Did I set it up for you guys?
Yeah,
Oh, it doesn't have to be there.
were we not supposed to?
No, the graph? Yeah, already. You guys are supposed to see that.
We are supposed to see?
Yeah.
Are, good.
That may not be the case on your exam,
Yeah, I don't think it will be.
but for this old exam, they did draw it out for you. So this is equal to the matrix of dx over du, and these are all partial. Dx dv, dy over du, dy over dv. All of them partial, not full derivatives. That you do need to know. So Don't forget that. That's essentially the same variable. On each row has the same variable. Each column has a different u or a v. So what is partial of x with respect to u? We keep v constant, right? So wait. Because this is equal to, I'm going to explain this quickly, u over 2 minus v over 2. Okay, so this is a constant right here. So the derivative of that is 0. The derivative of u over 2 is 1/2. So we have 1/2 right there. What is with respect to v? Negative 1/2. So just again, this is equal to u over 2 plus v over 2. So what is partial of y with respect to u? 1/2. And
then the answer is
1/2. So to do the matrix, we do the cross multiplication stuff. So in this case, we have 1/4 minus a negative 1/4, and that's equal to 1/2. Any questions on that? Yeah, you solve the matrix. It's called finding the determinant of a matrix when you do that. The second part is to sketch the G region. Okay. So to do that, you need to convert all the equations of x and y to u and v, right?
right.
So the 4 equations, which I did not write but were on the graph that I drew for you, is y equal to x plus 1, y is equal to 1 minus x, and then y x minus 1, x minus 1, and then y is equal to 2 minus x. So this graph I had drawn for you on the old exam. Do you want me to draw it up here? No?
How would you get that without the graph?
So on your exam, they might just tell you this and tell you to draw it. But you do need one of these. Essentially.
They did, like on our homework, they made us solve.
The intercepts and draw it? Yeah.
Can't you just draw the equations and then it'll intercept
Yeah.
naturally?
Yeah.
It's a lot less work.
So on this, they probably did do it for you to save time, that sort of a thing. But on your exam, they might think there's enough time for you to do it. So we know what y is equal to. We know what x is equal to. So we substitute that in. Y was equal to u over 2 plus v over 2 equal to x was equal to u over 2 minus v over 2, and then we have plus 1. Okay. So those cancel out. V over 2 plus v over 2 is just 1v. V is equal to 1. Okay. On this one, y is equal to 1 minus x. So we have u over 2 plus v over 2 equal to 1 minus quantity u over 2. So then we have plus v over 2 in this case. So you guys see that? Because it's minus v over 2, but we're subtracting it. So then in this case, the v over 2's cancel out. We bring the u over 2 to the left, and we get u is equal to 1. In this equation, we have x minus 1, so we have u over 2 plus v over 2 equal to x, which was u over 2 minus v over 2. minus 1. Okay, so the u over 2's cancel out, and we are left with v is equal to a negative 1. Yep. In the last one, we have 2 minus x. So we have u over 2 plus v over 2 equal to 2 minus, so we, in this case, we have u over 2 plus v over 2. So then the v over 2's cancel out, and we get the equation u is equal to a 2. Any questions on this process? It's just converting them to u and v. So don't, like, make sure you do it right and don't make mistakes with that, because then you'll just lose all the points. Well,
No way.
You'll get
I
some.
didn't know that.
points. Okay.
Just do it right or you'll lose all the
Yeah.
points.
So u is between 1 and 2. I'll just v is between 1 and negative 1. And this is our region G. So we are going to find the use to evaluate for the region G, and we do have a function y squared minus x squared.
We have to convert that to.
Yeah, when you have your integral, you will convert. So any questions on this part? So we have the integral. So alrighty. So the integral has y squared minus x squared dx dy. So we have to convert everything. So here we will have y squared, and we knew y was u plus v divided by 2. So that quantity squared minus the quantity u minus v over 2. That quantity squared. Okay. So now what do we need to multiply by? The absolute value of the Jacobian. So we have, and what was the Jacobian that we found? 1/2. Where did it go? Okay. So now we have du dv. Okay. So the denominator that we'll get while we square these is what? 1/4. When we multiply by 1/2, we get 1/8. So we can go ahead and put 1/8. Oh, we forgot our limits. What is u between 1 and 2? Did I write that? Yeah. And what is v between? Negative 1 to 1. So I'll just write over here. 1 to 2, negative 1 to 1. We can take out a 1/8, and then we can simplify those quantities squared. Okay, so we have u squared plus 2uv plus v squared minus the quantities u squared minus 2uv plus v squared, right? And we have du dv. So the u squareds cancel out, the v squareds cancel out, these two can be added. So we're going from -1 to 1, going from 1 to 2. We have 1/8 on the outside, and we have, so what do they add up to? 4 UV, so, and then we have du dv. The 4 can make the 8 a 2 in the denominator. Okay. So this is u times v. In a double integral, we treat the v like a constant since we're doing it in terms of du. So this is equal to 1/2 going from -1 to 1 for the limits for v. You have u squared over 2 going from 1 to 2 dv. You guys good with that? So I'm going to write up here now. So we have 1/4.
Hey Daniel, are you also supposed to have a v in that 1/2?
Yeah, sorry. So we still have a v that we work with. Thanks. So we have 1/4 times 2 squared, which is what? 4 minus 1. And then we have now v squared over 2, right? So then I'll just write it this way. Going from -1 to a 1. So this is equal to so 4 minus 1 is a 3. So we have 3 over 4 times 1/2 times 1 squared minus a -1 squared. So this essentially, sorry, it'd be a 0, right? It'd be 1 minus a 1. So then the whole thing is equal to a 0.
What does that 0 mean? Does it mean there's no area? What does that mean?
It's not that there's no area. You could think of it like that, but the issue with that is that's not the case with the x and y. With the dx and dy, you actually have a region, right? But you have to look at it. There is a function in the double integral, which was y squared minus x squared, right? So then once you work with that function as well, then the area, even with dx dy, would come out to be 0. Should be.
I don't know. Interesting.
But
I agree with Charles.
I don't. In my mind, the Jacobian problems aren't hard. They're just like you just have to do a lot of algebra, right?
I would like algebra.
To find the equations in terms of the other variables. And that is it. Thanks for coming.
Question.
Yeah.
What was the J determinant thing with the partials?
1/2.
I don't know. I mean, I don't know like what that goes in.
The matrix. Is that what you're asking? So
Can you remind me of that?
yeah. So it's like I'll write it out. So it's the matrix of the partial of x over the partial of u, partial of x over partial of v. So each row has the same variable in it. So the second row will have both y's in it, and each column has the same variable. So partial of y with respect to u, and partial of y with respect to v. Yep. and in the integral is the absolute value of it. So when you multiply by the Jacobian in the integral, you have to take the absolute value of whatever you get. So in this case, we got 1/2. But if you had gotten a -1/2, you'd treat it like a 1/2.
But wouldn't that come out to be like letters?
No, because when you do the it could come out to be letters.
I'm gonna go to the bar and.
But when we had u minus v over 2 and all of that, it just came out to be 1/2 and -1/2.
Oh, that's over 2.
Yeah.
Oh.
But that's a good point, though. The Jacobian could come out with variables.
They won't erase it. Jenny, I just realized they won't erase it, but they're just gonna erase it from the board.